Hello and welcome everyone to our very first Adoptium Summit webinar series. My name is Serena and joining us today is Hendrik Ebers, who will be presenting on the topic of how Temurin helps you get to a secure supply chain. If you have any questions for Hendrik as we move through today's presentation, feel free to ask it in the chat or use the Ask a Questions tab. Hendrik, without any further delay, over to you.
Thank you, Serena. Okay, yeah, thanks for having me, first of all. And I would like to talk about supply chain security, what supply chain security is, how it's done within Adoptium, and how that supply chain security can even be used for other projects to make the supply chain more secure for other projects by using Adoptium. I'm Hendrik. I'm from Germany, and I'm part of the Java open source community. I'm working on several projects on the Eclipse Foundation, on the Linux Foundation, and on the Apache Foundation. I'm a board member of the Eclipse Foundation. I'm part of the steering committee of Adoptium. I was one of the first members of the Adoptium project at Eclipse. And today I would like to concentrate on that topic and on the supply chain security of Adoptium and how it can be used by other projects. As an example, I show Hyro, which is the project of the Linux Foundation. Before we start going into Adoptium and what Adoptium does for supply chain security, I would like to talk about supply chain security in general, because to understand the benefits of the work of Hyro within supply chain security, it's important to understand what supply chain security even means. And let me tell you what it means to me, at least. So when I talk about supply chain security, I'm talking about processes and workflows that make a product, in this case, we talk about digital products, right? So a digital product more trustful. And to make it more trustful, there are three main steps how a product is created. First of all, we have the source code. This now shows C++, but it could be Java, it could be PHP, it could be JavaScript, whatever. So the source code of our product. Then we have the build of our product, where out of the source code, the real product is developed and built. And then we have this last step, which is packaging or distribution. And this is highly different on what digital product we look like when thinking about an open source library. This could be like distributed on an open repository like npm.js or Maven Central. Or if we're talking about a commercial product, this could be like providing a download of the product on our website page. And when looking at this super simple chain with these three components, this chain already has a lot of attack vectors where the supply chain of a software can be attacked, and vectors that can be used to create bad software, to hijack the software, and so on. So this in general shows the different points where attacks can happen. And as you can see, it's like at every of those components, but not only at those components, but even between those components. So let's make it clear, at every position of this chain, an attack can happen. And if you want to create trustful software and trustful software components, you need to be aware of that, and you need to learn how you can secure your supply chain to not others let your software be attacked at one of those points. When when talking about attacks, I mean like backdoors, vulnerabilities, maybe using unverified dependencies or libraries, or maybe having people with hijacked accounts that publish bad code under your name, whatever. So there are so many different ways how a software supply chain can be hijacked. Um, I've just put some examples here on this slide for each and every step. Like at the beginning, it could be that somebody submits unauthorized changes to your source code, or somebody could compromise your source repository. So this is already happening before anything happens with your source code. Maybe somebody modifies your build by committing an additional flag or by committing a build configuration that will harm your build, or even compromise your build process by putting in it a build tool that is already harmed. Maybe uploading to like a GitHub repository or somewhere else a modified package. So when coming to Java, for example, maybe not the jar you build, but a different jar that don't fit anymore to the source code where you think it is built from, but contains some malicious code. And or maybe you have a compromised package registry. Maybe somebody attacks the package registry by, for example, stealing your account and compromises the packages that you have uploaded to npm.js. Or maybe you just use bad packages because the download is broken and so on. So as you can see, there are a lot of different points in the supply chain that can be very problematic. And now people could say, yeah, I understand that this is a problem with open source, but we create this enterprise software in our company behind closed doors, so we are safe, right? I mean, there was not any problem. So actually, maybe that was like, it was a decade ago, no, way more than a decade ago, actually. But today, that is not a fact anymore, because even if you have closed source software development and think your full supply chain, your full software supply chain is behind closed doors, there are problems and your supply chain can be harmed because of your dependencies. So when talking about a real software project today, you can think about that this project, even if it's a closed source project, depends on 70%, or let's say it like that, like 70% of the full project are open source dependencies. So what you create is only more or less like 1/3 of the project, and everything else is coming from your dependencies that are normally open source. Which means when talking about a supply chain, if it's closed or not closed, you not only need to think about your code, your build, your binaries, but even think about your dependencies and about the supply chain of your dependencies. And now it gets a little bit tricky, right? Because they have, again, supply chains of their own, and they have dependencies of their own, and each of everyone can, again, have a problem. And if you see that picture, now that looks really scary, right? And a lot of things you now need to keep in mind. The good thing is, if your dependencies are safe and trustful, a lot of error marks or warnings that you currently see here on the screen are gone. On the other hand, maybe people say, yeah, we do not have that much dependencies. That is not that important. So I did a test to understand how much dependencies a project our days has. So let's assume you have within your infrastructure a microservice. So maybe you have like 100 different Okay, maybe you're not that big, but let's assume you have some software and your software is based on 10 microservices, for example. And now we will concentrate on one of those microservices. And a common pattern to create a microservice is, for example, to use Spring Boot, right? So, and what I did here is I used the Spring Boot initializer to create a super minimalistic Spring Boot application. I called it Spring Boot Hello World. So to be realistic, I said, okay, it should be a kind of a microservice, which means it should be accessible by REST, where I need Spring Web. It should have some storage. I decided to use JDBC here, so just have a database connection, and I need a database driver. For that one, I use PostgreSQL. Since this project should be trustful, one thing that we definitely need next to having a good supply chain is having good tests. So I added 2 additional dependencies, which is the Spring Boot test dependency and H2 as an in-memory database. And I've now switched to the next slide already too early, because now people can say, oh, that's cheated. Why do you add test dependencies on it? Test dependencies don't count when talking about what you're talking about. But that is not true. So let me tell you something. Test dependencies can be used to harm your code. Maybe if you've heard about the exact utils backdoor that happened earlier this year and could have become an horrible threat for the IT. Happily, it's not. But that backdoor was based on bad test files. So what they did with that backdoor, they used bad tests to harm the product and what is distributed at the end out of the product. So it's not that we can not take care about our test dependencies. We need to take care about those dependencies. And next to that, as we've seen, we not only need to take care about our direct dependencies, but even take care about our transitive dependencies. And while we now already have 5 dependencies shown here for this minimalistic microservice that we are more or less able to create in Java, if we do not want to do everything on our own, but use something like Spring Boot to create it. So anybody has an idea how much, when we include the transitive dependencies, how much dependencies our application has? So I tried that for you, and it's 73. So our application really has 73 dependencies that, to be fair, mostly we are not aware of. And those are just the dependencies for our application at runtime, right? I'm currently not talking about the JVM as a dependency. I'm not talking about build tool like Maven as a dependency, and so on and so on. So those are like really the dependencies that are used at runtime for the Java application, and that's a big problem, right? So that is something where we need to take care of, where we need to understand what those dependencies are, need to know where they're coming from, and at the end we need to trust them, right? And the question is, how can we trust dependency? So just to make sure, before we look at how projects can do that, I want to make clear that what I'm talking about is not a like a scare tactic from a consultant. It's law. You can say it like that, because the US has already defined laws that make clear how important supply chain security for software is. With the Executive Order 14028 and the Memorandum M2218, the US government defined rules and laws that specific points in the supply chains of software development needs to happen to allow to use that software in government and as part of software created for the government. There are things like an SBOM need to be there, what need to be part of the SBOM, and so on. And that is defined by law. And as you might know, on the other side of the ocean, in Europe, there will be a law for it too, which is the Cyber Resilience Act, that will start in like 2 years to be in place, and that is even people are working on it. Let's say, like, I assume it's even way more restrictive than everything that we have in the EU is. I've just put here the a screenshot of the official papers from the US on it with a link if you are interested to read about it and to read how laws and governments define minimal security for supply chains. And when talking about minimal, I don't say like, oh, they do minimum not enough. It's more like they define a quality gate, like a minimal bar, and you need to be better than that bar with your software to be able to use within the US government. And when coming back to Europe and the EU and the Cyber Resilience Act, again, I want to make clear that this is coming, and this is, for example, not like it was with GDPR. So when GDPR come, I don't know how much years that is in the past, a lot of people were afraid too, and presentations like I do now for supply chain security has been done for GDPR too, and people got afraid. And at the end, we all did it, right? So GDPR is working. There was a small period where we had some problems, like the New York Times I think it was the New York Times that was not available in Europe for some times to not run into any GDPR issues and so on. The difference with supply chain security and GDPR is that when talking about GDPR, you can concentrate on your product, you need to make it once, and you're good. When talking about supply chain security, you need to have your dependencies in mind, and in theory, since your application is moving forward and is changing, you need to be aware of it all the time. So this has, from my point of view, a way bigger impact on people working in IT than GDPR had. I just added here some an extract from the Cyber Resilience Act, and this is especially for open source software, because we're now coming slowly into the part of the Eclipse Foundation, Adoptium, and so on. I said I want to talk about Adoptium. So far, I haven't done it, right? But I wanted to concentrate on these basics, first of all, before I'm able to tell you what Adoptium did here and why with Adoptium we have a project that is, already before its time, because the things that are needed for the US laws, for the CAA, and so on, we already work on that in Adoptium today and did the last years, and already have a lot of success, and think we have a great prototype of a software piece that has a really strong and trustful supply chain with Adoptium. So, as said, it's time to take some action, as we did with Adoptium. So, what does it mean, and what action need to be taken? So, in general, I would say it's important to talk about supply chain and supply chain security to make developers, technical people, and deciders aware of what is coming, what is already there, where are possible threats, because only by doing that we can, develop standards and move everything forward by creating software that is really secure and can, based on that, be successful and not a big threat for markets, for communities, and so on. So the good thing is that a lot has already been done over the last years because people started to recognize those problems and started to work on it. So one thing that happens is that open source stewards reacted on it. So what is an open source steward? When talking about open source steward, I mean like open source foundations and groups in general that take care of open source software, that move open source software forward. And I'm so happy that again all this work happens in open source and comes from open source foundation and shows how it can be done, how it should be done, and being a real role model for software development in general. This just shows to me how important and big and powerful open source and the open source community is today. And as you can see on this slide, there are a lot of companies, a lot of stewards, a lot of foundations. I've just mentioned here the Eclipse Foundation, the Linux Foundation, and others. I even do work with my company by, for example, moving Apache Maven forward and work on their supply chain security. To create a base that can be used to let you create software in a secure and successful way. Hey, our first Adoptium slide. So I don't do a deep dive into what Adoptium is. So I do not have like an introduction slide for Adoptium or something about that. I think the most important part is here on this slide, just by seeing this number of downloads. I think I don't need to describe more to say that when talking about Adoptium, we talk about critical infrastructure. We talk about software that is used that much around the world that it's really critical. It's used in bank, it's used in insurance, it's used in power supply, it's used in medicine, it's used just everywhere. And it's coming from the Eclipse Foundation, and with Eclipse Temurin, that is exactly the software that has this absolutely awesome download count. The Adoptium Working Group provides the only vendor-neutral Java binaries on the world, and I think that is why it's so successful, right? It's a vendor-neutral product that is developed by the leaders of the industry, including companies like Red Hat, like IBM, like Microsoft, like Google, like Azure, and so on, working together with people that come from smaller companies but be expert on this group. Like in Germany, there's the IJAC, which is like the work of all the German Java user groups coming together that are part of Adoptium. I be part of Adoptium with my company, Home Elements, as said. And that makes it a special project that is very important from my point of view for our IT world today. And with that in mind, we started quite early to invest a lot in supply chain security and in creating open and transparent supply chains. So already at the start, the supply chain from Adoptium was as open as it could be, which means like we are Adoptium, so Temurin is based on the OpenJDK, the open sources of Java. So the source is open source. The build scripts of Eclipse Adoptium, independent if it's Temurin or other projects under the working group, are all open source, which means the project is fully auditable. Everybody can do, and I will come to that point in a second, can do a security audit of the project. If you say, I want to be based on Java runtime for my super critical software, you can hire somebody like a security expert and let him do a security audit on Eclipse Temurin. And that can be done because the build scripts are open, the sources are open, and the builds are open too. So being open don't mean that everybody can change it, right? Being open means that you can look into it. And that's so important. You can look into the builds of Adoptium and see what happens there. And if you want, check that everything is correct. And that is so important when talking about critical software, critical infrastructure, and supply chains. But that's not the only thing that is important for supply chains. So another point that is important for supply chain, and I will only talk a minute about that, is, as we've seen already, tests, right? And I don't have a slide done for that because this is not our core topic today. And what Eclipse Adoptium, for example, does, it has an awesome project which is called Aquavit, and that is a fully open source test suite for Java binaries and Java runtimes. And it's the only open source test suite for that. Right? There is the Java TCK, the Java Test Compatibility Kit, that is provided by Oracle. We have already one, but the problem with that one is it's closed. You as a company need to contact Oracle, you need to create a contract with Oracle to be allowed to use it as a test infrastructure to run tests against it. And you're not allowed to tell anybody about the tests and about the inserts of it. So while I'm not saying that it's like that, we cannot say if the quality of the OpenJDK TCK is good enough to really say today what we are building here is really secure. With Aquavit, that is coming from the Eclipse Foundation, from Eclipse Adoptium, we can, because all tests are open, all runners are open. You can look into the tests, into the results, and you can even contribute tests if you see that something needs to be checked and is not checked today. Then you can easily add it to Aquavit, and on the next day, when the next time Adoptium or Temurin is built, it will automatically be used your test to test like the Temurin binaries for Mac, for Windows, for Linux, for so many different platforms. And that is huge. So next to that, two important things that have been done for the supply chain of Eclipse Adoptium are reproducible builds and the provisioning of SBOMs. So let's start with reproducible builds. What is that? So a reproducible build means that you can take the same source code and build it 2 times, even on different hardware, and you will get the same result. And when it sounds easy, right? It sounds like, yeah, I mean, for sure, I built something 2 times and it should be the same because otherwise it wouldn't work. But in reality, that is not often the case, because when talking about reproducible builds, we talk about having 2 binaries, because that's the output of a build, right? Who are byte by byte are equals, where the hash is exactly equals. And that is still today not common. And there are a lot of low-hanging fruits you can do. I mean, it starts with when you build, putting the date of the build into the binary. That is already one thing that will end in not reproducible builds, because the binaries will be a little bit different at the end. Another thing is that you use, for example, the system character for a new line, which is on Windows, different than on Unix system, which could then again end if you put it into a jar or something like that in different builds. So there are a lot of things you can do to not have reproducible builds. And what Eclipse Adoptium and the people working at Eclipse Adoptium did is they made Adoptium 100% reproducible. This goes down up to the OpenJDK. So we, and when talking about we, it was not me, but it was a group of Eclipse Adoptium, did contributions to the OpenJDK that at the end allowed us to create reproducible builds of Adoptium, which means if you download Adoptium from our webpage and next to it build it on your own, on your machine, you could compare those two byte by byte and will have exactly the same result. And that is important because by doing it like that, you can prove that when depending on Adoptium, that your dependency is correct. And if whatever you build on top of Adoptium is reproducible too, you can put those two together and have a reproducible artifact that can easily be checked if that is harmed or if that is correct. And the second thing that is mentioned here are SBOMs. And when talking about SBOMs, that's again is a quite complex topic, and topics that came up, I would say, maybe the last 2 years. So what is an SBOM? An SBOM is a software bill of material, which means it's somehow a file that contains important metadata of the software. Those metadata includes like, how is the software built? What is used for the build of the software? When is the software built? What dependencies are used? And so on, and so on, and so on. So by, and the good with the SBOM is you could say like, oh, I have that. That is what I have with a POM in Maven, right? So like a POM XML, or that is what I have with a package JSON when doing a JavaScript project. The big difference with a BOM, with an SBOM, is that you have here language, build to, and so on, independent standardization, how such information look like. And by doing it in that way, you can easily create tools that can read your SBOM independent of it's a Java software, it's a JavaScript software, and so on, and use it to check if your software is secure by checking your dependencies, by checking your build dependencies, your build tools, your test dependencies, and so on. So that is like, not the history of your project, but where your project is built on, right? And by knowing that, you can check if your product is based on or depend on something that is not trustful. And as said, another thing that we did with Adoptium is that, and that is again a benefit of the open source foundation and being part of an open source foundation, that we were able to do a security audit. And we did a security audit about the Open Source Technology Improvement Fund, which is an organization that does security audits on critical infrastructure, critical open source projects. And they did a audit on Eclipse Adoptium with very good results, right? So with that in mind, next to what I've showed you and told you so far about what we are doing in Eclipse Adoptium, we now even can say, like, even others approved that we are really solid, enterprise ready, and secure, which at the end means being trustful. But there is more. Now again, I will leave Adoptium a little bit and talk about what you, with your project next to that, can do when talking about having secure supply chains, being ready for the Cyber Resilience Act, and so on. So one thing is now switching from the Eclipse Foundation to the Linux Foundation is OpenSSF, which is a sub-foundation of the Linux Foundation that concentrates on software security and software supply security. And what they did, for example, is they created this security scorecards that can be used to analyze projects. And here you can see that we use it too, right? So here you see a screenshot of the Temurin build, which has from a maximum out of 10, that is the best result yet that you can have, an 8.2. And that is very, very, very good. And as you can see, everything you see on the screen, even the ones that are critical, and this is, as you can see on the right, sorted by risk level, mostly everything is on a 10. Token permission is a thing that is not needed here, and that's why it's 0. So it could be ignored. I don't know if that can maybe configured in future to be ignored to make our score even higher. I'm not deep into the scorecards. That's why I cannot tell more about that. But that is great because that can be used by each and every project, and it don't took much time to set it up. To already get results and numbers for the project. And if your project and your dependencies have it, you know much more about your project, about the security of your project and the security of your supply chain. And now switching again back to the Eclipse Foundation, where a new working group has been created this year that is awesome, which is the Open Regulatory Compliance Working Group. It's ORG, if you call it short. And this is a working group of foundations, as you can see on the right. And sadly, I missed to update that slide now that I see it, because a lot of important companies that are now part of this working group, like Mercedes-Benz, like Siemens, like Nokia, and so on, are currently missing here. But I think one thing that is important is seeing here, you have the Apache Foundation part of it, you have the Python Foundation be part of it, the FreeBSD Foundation, the PHP Foundation, Open Forum Europe, the Rust Foundation. So this is not a working group like other working groups where companies or individuals come together to create some software. No, that is really a working group where foundations come together to define best practice for supply chain security. And with Eclipse and with having projects like Adoptium that already show like this can look like, or how this can look like, this is really a great fit. And the working group has been created shortly in the past. Was it the last quarter of this year? I think it was started in the last quarter of this year. So this is still quite new, but has the goal to really move supply chain security forward, to create open definitions and regulatories to help open source software and software in general to be compliant with the Cyber Resilience Act and so on. And that is really important. And with all that we've seen so far, like projects or like general rules for supply chain security, projects like Adoptium, and the work that all the stewards do by creating scorecards, by creating working group like this, or even by doing audits of the software, we have a very, very good base for open source and open source software to be ready for the future and to be really secure. What needs to be done is for sure that open source maintainers and committers be aware of that, take those best practices and move them forward within their own projects. And that is something I did. It's coming, I mean, you've seen my company logo now on several slides, like we are part of the Open Regulatory Compliance Working Group, part of Adoptium, and so on. And what I'm currently working on is at the Linux Foundation, the Hiro project, where I work on as a part of the Hashcraft company and leading the technical steering committees there. And what Hiro is, to give a short introduction, I don't want to deep dive into Hiro and what it is. It's a project coming from Hedera and the Hedera network. Maybe you've heard about Hedera, and it's you could simply say it's the open source and vendor neutral base of the Hedera network, because with the creation of the Hiro network, Hedera is currently, or we are currently moving all source code of Hedera that is used for the Hedera network and for all its clients to Hiro, so to the Linux Foundation, which ends in being the first fully vendor neutral and open source distributed ledger technology. That is what Hiro is all about. If you are interested in Hiro in general, in distributed ledger technology and so on, feel free to ping me, create contact with me. I don't want to go deeper into that topic in this presentation today. I just can say it's an awesome technology. Here I just put a slide like everything as we've seen it with other projects today. I'm trying to take all these best practices and use it in Hiro too, by, for example, being as open as possible, which from my point of view is like 100% open regarding the transition of the project. So I've created this kind of metrics where you can, for each and every project that we transfer to Hiro, see what the current state is and so on. All that happens 100% in the open. To understand why the topics we talked about are so important for Hiro, I would like to give to show a short real use case of Hiro, and in that case the Hedera network that is based on Hiro and using the Hiro technology and the decentralized technologies that are now part or defined in the Hiro project. And for this real use case, I've decided to use a non-technical use case to make it as easy to understand for everyone. So let's assume you live in South Africa, and maybe you have a colleague or a family member or whatever, or maybe you even buy something there in South Korea, and you want to transfer money from your bank account in South Africa to your bank account in South Korea. Don't sound that problematic, right? I mean, it's a bank transfer. We do that every day. So being more concrete, let's look at two specific banks. First of all, the Standard Bank, which is the largest bank in Africa, and then the Shinhan Bank, which is like the leading bank in South Korea. So let's assume you have an account at the Standard Bank and want to transfer money to somebody who has an account in Shinhan Bank. And it's not that I've used that example because that is, different to any other banks. As you will see later, I used those two banks because we work together with them. So what do you think? How much does such transaction costs, like in kind of paying a fee for that transaction, and how long does it take for that transaction to happen? We're talking about a bank transaction, right? So those two banks did a research on it, and they found out that doing such a transaction costs a minimum of $40 fee. You send $1 to the other account and you need to pay $40 of fee, and it needs up to 6 business days. And the important thing is your business days, right? It's not days. So business days means if there's a weekend in the middle, it could take up to, I don't know, nearly 10 days to get your money transferred to another account, and you cannot track that, right? You send your money like by doing online banking or whatever on your side, and then maybe for 5 or 6 or 7 and 8 days, you have no clue what's the status, if it works or not, until boop, on the other side, the money just appears. So that is kind of problematic. And for me, it was even shocking to see how bad those numbers are in our days. So why is it like that? It is like that because when such a transaction is done, it's not one single transaction. But as you can see on this slide, several banks are involved in that, which means several transactions are involved in that process. So, and while each and every transaction is done digitally nowadays, we have no idea what if there need to be a man in the middle that takes one transaction and starts the other one, and so on and so on. And that can really take days. And what the two banks did based on that, they created a proof of concept by using the decentralized technology of Hedera to create an application, a decentralized application that can be used to make those transactions 100% digital as part of the Hedera network. They used something for it that is called a smart contract. So that is something that comes from the Web3 world and distributed ledger technologies. I don't want to go deeper into that, but to make it as simple as possible, you can think about that. So what they did is they created a digital currency that is related to the South African one. They created a digital currency that is created to the South Korean won, and said like, okay, those two currencies for us are as much worth as the real currency, which means like one of those digital South African rand is for them worth one real South African rand. And I'm not telling that you can now go to Coinbase or Binance or whatever and trade those currencies. No. Those are internal digital currencies for those two banks. And they created a lot of it and exchanged more or less half of it. And by doing so, they were able to do the full transactions that before needed all those banks on the Hedera network with digital currencies. And by doing so, they came up with a solution that cost less than 10 cents. And let me tell you, that is super expensive when talking about what in theory Hedera or what you need to pay to Hedera to do that. And it took less than a minute. And again, in Hedera, it would take way, way less than a second. This is more like everything that happens then outside of the network. But the good thing is it's real-time trackable, even on the Hedera network. So that was a success. And as said, I don't want to go deep into the Hedera technology. I just wanted to give you an idea what you can create with a decentral network in enterprises and how it can be used to create enterprise-based applications. And there was one point that is really critical when having scenarios like that, and that is trust. So when creating a Hedera or creating Hiro now, one thing that is super important for us, and now we come back to the beginning of the session, is supply chain security. Next to several other topics, a secure supply chain is needed to create trust in the product Hiro and then trust in the product Hedera. And we achieve that by depending on products and partners that are trustful. So we're using the best practices coming out of the OpenSSF. I be part of the ORG working group, the Open Regulatory compliance working group at the Eclipse Foundation to bring all that knowledge into Hiro. We all our Java applications, and the network is based on Java, are running on Temurin because we want to be reproducible. So we need a reproducible build. We want to be trustful. So we need trustful dependencies, and that is what Adoptium is, right? Because it's not a black box where we don't know how it's created, where it's coming from. Adoptium is something we can trust on because it's open and it's solid, and we can, if we want, double check that it's trusted and solid, because we could build it on our own and check the the bytecode of it based on the reproducible builds. We use the S-bombs of Adoptium. We can even, if we want, hire an auditor, maybe the Linux Foundation will do that in future, and check if everything is fine. And that auditor will have an easy work because by depending on Adoptium, he can depend on the audit that has been done for Adoptium, which is a huge benefit. So when putting this all together, right, and I think there was one term that I used a lot in this presentation, and that is trust. So how can we create the trust that we need for critical infrastructure and for critical software today? And I'm not saying Adoptium is equals trust, why it is. I'm trying to be more general and say, like, transparency is important. Transparency is trust. As supply chain security is trust. As vendor neutrality is trust. As the community is trust. Because if we know who's working on something, if we know the real persons, that's an important factor of trust. Collaboration is trust. And with collaboration, I mean projects working together. Like, I'm working in Adoptium, like I'm working in Hiro, like I'm bringing those projects together. Like, my company is working with Microsoft and Red Hat together on Adoptium and collaborate on creating a very good software solution. And last but not least, open source is trust, because only by having the sources open, we allow others to audit it, to understand it, and to decide on their own if it's trustful or not. And I could now easily say Hiro has all that, and I'm happy that I can say this. But part of it means Hiro has it because Adoptium has it, right? Because Hiro can only have it as long as we use internally or based on components that have it too and that we can trust. And this is what really all of us need to understand, that what we see in our software is only the top of the iceberg, right? It's only 1/3 of the software. 2/3 are the components our software is based on, and they need to be as trustful as possible. And with software like Adoptium and stewards like the Eclipse Foundation or Linux Foundation and so on, we can really achieve that. So I took way longer than I expected for that session. But anyway, I come to an end. And I hope you like that presentation. If you have any questions, independent if it's about supply chain security, about the Cyber Resilience Act, about Hiro, about Adoptium, please create contact with me. I'm happy to help you. I'm happy to introduce you to the right people, to the right communities, to get your software more secure, move it forward, and so on. Yeah, that's it. Oh,
Thank you.
Serena, I see you. Hey,
Yes. Hey, how are you? It went really
I'm
well.
good.
Thank you. Thank you so much for that excellent presentation. So I'm just going to encourage the audience, if you have any questions, to put them in the chat or use the Ask a Questions tab. So before we get to that, though, we want to encourage, this is the very first webinar that Adoptium is hosting today, and we really look forward to having many more in the new year. So I will be linking the form in the chat so that you can click on and submit a talk as well. So it doesn't look like we have any questions, Hendrik. Thank you so much again. Happy holidays to everybody, and wishing everyone a happy new year as well.
Absolutely. Same from me. Thank you.
Take care.
And again, thanks for having me.
Thank you so much for coming.